So I sent an email home yesterday as I was looking at how are we going to be wrapping up the term, and realized that, you know what, we've all been struggling with all of this computer stuff, okay? I get that. And so literally this is kind of pretty much my email home to people. I've gotten a few replies so far, but not from everyone. And this really applies to every single person in the room, in one way or another, or both, okay? So this is your last chance this week to really improve your grades. Now, we had 3 test grades for this term. We had our chapter 1 test, okay? We had our formal lab report, and we have our chapter 2 test. Now, some people have not made efforts early enough on to try to do better on some of those things, okay? You know, come in to try to do a retest or things like that. And so this is their last chance where on Wednesday after school, and I need an email from a parent or guardian. Now, some of you, like, you just want to check with your parents, make sure, you know, have they emailed or not. You have a chance that if you have earned a 75 or less on either of those 2 tests, to come in and do 1 test. Probably the lower grade of the 2, but maybe not. Maybe you just decide, hey, I can do more if I focus on this particular one rather than the other, just because I feel more comfortable, like I could get a better grade. So I need your parents to email me. That lets me know that they know that you will not be picked up, you know, right at 2:40 or whatever that day. You will come to me and we will be done by 4 o'clock that day for whichever test you're retaking.
So, we are retaking the test on a Tuesday?
On a Wednesday.
Wednesday, okay.
That's why it says on here Wednesday. Pretty sure I said that somewhere.
Scroll down.
I guess
It's right there.
Yeah, well, it says students or their families must email me by Tuesday.
The second point.
Yeah, the second point says, so I've said here, if you score 75 or less, or really less than 75, you can retake one of those 2 tests. You have to email me by Tuesday, so I know that you're coming. You have to be here in the room before 3 p.m. That doesn't mean like going to band or going to the WAC and, oh, well, I decided I need to go see another teacher and then I'm gonna come later. Like, I can't. Okay, you guys stretch out a whole lot of my time, which makes it difficult for me to get grading done for other classes. So this is your time. And we're gonna be done by 4 p.m. So you can let your parents know, hey, after 4 I can be picked up or whatever. We also have an opportunity that for the formal lab report, if you score less than 75, once again, you can look at the Google comments for your particular lab, make changes necessary to try to bring that grade up to a 75. In each of these cases, for each of the exams or each of the reports, I have people that have scored really high. And each one of us has fallen down on at least one thing where if I can improve that up to a 75, that's gonna make a huge difference for your grade for this term, okay? We make mistakes, this is our time to kind of follow up and try to make sure that we're better on it. What I think I'm gonna do today, I remember if I actually had said anything due for today. Let me go take a quick look.
You got Queens on Blue.
Due today. I have, go back to here. Starting for this week, you should have finished up and turned in your Cornell notes for
1 and 2.
No, just one, actually.
Yep.
No, sorry, Bella is right. Bella is right. One was due last week.
Yeah.
Not everyone's got one in. I know that because I was grading them yesterday. A lot of them were not in existence.
Yeah.
Okay? People might be reading their textbook, but then they're not actually putting anything to paper or like using the Cornell note template. There's a template, you know, as far as Cornell notes go, I'm looking for the format. I'm reading through, and some of yours, like, you want to go back to your Cornell notes, look at those comments, because some of the stuff that you guys are doing isn't making sense. Either we're not using the left-hand column properly, we're forgetting to write summaries, we're forgetting to write any notes at all. Use that template. The template is available right up here in Classroom Tips and FAQs. You can see here's a Cornell note template. Just make sure that you get rid of the template information where, you know, I filled in an example for something later on in the year. Okay? You shouldn't leave that template information in there. But you can type it up. Like as you go along, have that open so that you can start putting information in and then summarizing that in the left-hand column and then writing that main summary down at the bottom. But if you aren't doing that, that's what's affecting your test grades more than anything else, because you're barely making sense of what we're covering in class if you haven't done the reading and the notes. Now we could switch it if you want, like we could come to class and we could do all the notes, and then I just assign all these things that you have to figure out on your own. But I figure, like, what's so hard about figuring out how to do Cornell notes? It's just the fact that it takes perseverance and time. So I think that's a more fair homework assignment to make you guys do the notes on your own, and then we talk and do the activities in class. Should we take a vote to, like, if we need to switch? Do we need to do, like, notes here and activities at home?
No.
Okay? Who would actually rather do the notes at home and then the activities here? The majority. Now that means you guys are responsible for taking those notes. And from what I've seen, let's just say roughly half of you aren't taking the opportunity to make sure that you're learning at least some before you get here. Make sure that you do those. It's only a couple times a week. I don't think I've ever had anything where it was more than like twice a week so far. There might be some that there might be 3. But reading like 5 pages at a time, twice a week, that really shouldn't be so bad. And take some notes on that. Okay? I can really see your thought process in the notes. I really can. And all of yours look a little bit different. But make sure that they are complete. It doesn't mean it has to be word for word, but I need to see that you've read the content and you're picking out the important information. Okay, making sense of it. So what we have for this week, lesson 8, I have, starting off with a reminder that your final Cornell notes for section 3 or lesson 3 are due for Friday. Okay, so you have like multiple days. I want to look at a couple things just so we can get it out of the way today. But then what I'm going to do is give you guys some time to work on things, to work out what you need to improve on. Whether it means starting to look at the reviews again for your tests, or working on that lab report to work out how I can resubmit that for a better grade. Okay? So what can people tell me about ions to start off with? You guys have done the notes, or you should have done the notes, should have done the reading. What can you tell me about ions? What is an ion? Oh, I see some people Googling. What do we think?
It has a charge according to like.
Okay, and so it's an atom that has a charge?
No, yeah. It's
Yeah.
an atom that has a charge, but it's
like a wording to how many electrons, like combined.
Yeah, okay. So it's an atom that has a charge based on how many electrons it has. Now we said a neutral atom had to have equal amounts of,
Protons and
a neutral atom has
Protons.
equal numbers of protons and electrons, because the pluses and the minuses have to equal. But we know that some of these have extra, like 1 or 2 electrons that are valence electrons that they want to give away because they don't feel stable. Even though that they don't feel that way. And then there's other ones on the periodic table to the far right that have lots, and they're like, oh, I just need a couple. Okay, they just need a couple more valence electrons. And so there's this exchange or sharing that may happen, and that results in these particles having different charges. Okay?
So when they bond and they like trade electrons, does the proton numbers go up or stay the same?
The proton number stays the same. If the proton number changed, it would become a different element. They do not change their identity, they stay the same elements, but suddenly they have that little extra charge, or they've lost a little charge. Okay? If I gain an electron, if I gain more negative, will I be a negative or positive ion?
Positive.
Negative.
Right.
Do you even know what the question was? Okay, let's listen carefully. If I am an atom and I gain electrons, if I gain an electron from somewhere else, have I become a positive or a negative ion?
Negative.
Why?
Because
Why am I negative?
if you take or added or have more electrons,
I have more electrons than
protons.
I have protons because I have that extra one. Okay? If I give away an electron, you know, I am stable, but I gain an electron, I lose an electron, I give it away. If I give that electron away, am I positive or negative as an ion?
Positive.
Negative.
If I give an electron away, I say, here, take this electron.
Negative.
Okay. Let's look at ones like Na and Cl. So what we know as table salt is NaCl. Okay? Na is group 1. Okay? How many valence electrons does a group 1 atom have?
1.
It has 1 valence electron. I'm going to shorten that to this E with a minus. Chlorine is in group 17. It's one of the halogens rather than the alkali metals. This one has 7 valence electrons. Now, if this guy, sodium, only has 1, okay, they tend to give that extra 1 away because, you know, it's just a little bit, right? If sodium gives away one of its negative electrons, it now has more protons than electrons. Would you agree?
Yes.
If it has more protons than electrons, what charge is it going to have?
Positive. Because protons have positive charge.
Oh, that makes sense. Because there's more protons and protons are positive.
so now this becomes positive because it has the same number of protons as before, but it has one less negative, especially if it gives it away to something like chlorine. Chlorine says, hey, I see that you have that, just give it to me. I need like one more, that's all I need, just hand it over. Okay? So this one, chlorine, gains one electron to complete its 8. This one now will have 0. Okay, this changes and becomes 0. But we gain one here, so we now get 8. If I gain an electron, I now have one more electron than I have protons. Protons and electrons, okay, I'm not neutral anymore. That extra electron made me negative. And so you have this happen with our with our metals here on the left and our non-metals on the right. Okay, they're the ones that form this kind of bond. Okay, Na and Cl combine when Na says, excuse me, sir, here, take it. Okay, and chlorine has C7 and it feels like this big bully, just hand it over. Okay, this is that bully scenario. If I have metals that will give, combining with non-metals that are big and they take it, they form an ionic compound. Okay? That ionic compound means that these electrons that these little guys have go all the way over to the nonmetals very quickly, very easily. It's a very strong bond. Okay? So these are the bullies. Nonmetals as a whole, whenever they're dealing with metals, they're the bullies. And I make a connection and go, well, metals normally sound really tough, don't they? Like we think metals is really strong. But aren't they the ones that are malleable and ductile? Although they might seem like they have a tough exterior, they're really kind of softies. Okay, so malleable and ductile metals give those few electrons that they have that are valence electrons over to the nonmetals. And the nonmetals don't even say thank you. Okay, they just pour their poor metal around like, they've just taken away his lunch money. And that's how we form ionic compounds. So we're going to look at a couple things really quick. And then I'll let you start looking at your test grades. And we'll actually give you some more time to look at those test grades, figure out how to improve them tomorrow. Harmony?
Are we gonna have a quiz today?
Today?
Yeah, it was on
No.
Redweb.
There's a quiz on Redwood?
Yeah, and it's on a little classroom too, under week 8.
I do not see a quiz today. There's a quiz due October 12th.
That's what if you go to stream and you click respond for the first half one, it's right there.
Well, seriously, what I have here, this is the next quiz.
It's also referred to.
It's on one point.
It's on October 12th.
Yeah, yep.
So it's not today.
3.1 is on.
3.1, yeah, is due today. You can do that on your own.
Oh, okay.
Okay, we had a couple things from last week. If you want, we can take the time to do it together and then you do more stuff on your own, but
What about the summary? Or how do ions are created or formed?
yeah, that's honestly what I was about to look at. Okay? This stuff was assigned last week and I feel like you can do these two on your own. They are due for today. If you guys want, I can pull these forward so you have them in this next week, but they were assigned last week to finish up for today. And this is what I was looking at today was really, I was hoping to get through how do ions form and the chemical formulas. If that's okay. Okay. So let's take, we just talked about how ions form. And I'm gonna have to log in. Now you notice that, I'm saying, hey, we're wrapping up even though we're only at lesson 3.3 by the end of the week. Because really we're gonna do some additional work on this bonding next week. And we're gonna have a test just on bonding the week after that. Okay, I like to separate these out before I start looking at chemical reactions. So let's take a look at this. So you can find it in Google Classroom. Get a lever open. We're looking at this how do ions form summary. Okay? When an atom loses a valence electron, it loses one of its negative charges and becomes a positive ion. And when an atom gains an electron, it gains a negative charge and it becomes a negative ion. That's just what we discussed. An ion is a group or group of atoms. Ooh, I can have more than one atom that combine to form an ion. There are some very particular ones. I won't ask you to memorize them. Any ions that we use, if I have them on a test, I will tell you exactly what they are. I'll give you the information for them. But when you do chemistry with Mr. Haddad, that's something he'll ask you to actually memorize. Okay? An ion is is an atom or group of atoms that has an electric charge. It does not have the same number of protons and electrons. That's what creates that ion, is the fact that we have handed over or taken from, and we have an imbalance in the number of electrons now in order to fill that outermost shell. Positive and negative ions attract each other because oppositely charged particles attract. Okay? The attraction between those two opposites is called an ionic bond, and the substance is called an ionic compound. Ions that are made up of more than one atom, this is an important thing to note, is a polyatomic ion. What does that name mean? A polyatomic. Yes, Bella?
Many atoms.
Many. We have more than one. We have many atoms that make up that ion. It says ions are usually formed by the elements on the edges of the periodic table. Okay, the most common ones that you're going to see in ionic compounds, you're going to see groups 1 and 2 combining with 16 and 17. They're the ones that have 1 or 2 valence electrons, or only need 1 or 2 valence electrons. Okay, so they make their handoff very easily. Which group doesn't need valence electrons, or to get any valence electrons from elsewhere? Do you guys remember the name of that group? Which group doesn't need to bond with any other elements? Who has noble gases. Remember, they kind of stick their noses up in the air. Now, do all of the noble gases have 8 valence electrons?
No.
Which one does not?
No.
Which noble gas does not have 8 valence electrons? Oxygen is not a noble gas.
What about helium?
It is helium. Remember, those top corners are special characters, right? Helium on the top right, it doesn't have 8 valence electrons. how many does it need to be full?
2.
2. The innermost energy level on that Bohr diagram, that first period is only 2. After that, it becomes 8. Okay? So, it says using the cartoon, explain why potassium becomes positively charged and fluorine becomes negatively charged. Okay, I need you to write your answer, type your answer into this particular assignment. So potassium, and you can tell it's potassium by its little shorts. It's got a K on his shorts. He says, I'm about to lose an electron. Fluorine says, are you sure? And you see their mouths? Their mouths show neutral, they show like nothing. And then in the second one, he says, I'm positive, and his mouth is changed to a plus. And her mouth is changed to a minus sign. So tell me why potassium becomes positively charged and fluorine becomes negatively charged.
So ions form when 2 atoms share an electron.
Not share, it's a give and take situation. Literally, that electron no longer belongs to potassium, it goes straight to the fluorine. Fluorine is just literally a big balloon. Fluorine has a lot, it's big and strong, and it just says, hand it over. Yep. Metals and non-metals, it's not a pleasant situation. You know, you think about the non-metals, they're very brittle. They form these solid crystals. They're like rock. Versus the softies that are the metals that, you know, allow themselves to bend and be pulled into long wires.
What's your side you did?
How do ions form? How do ions form summary? Now, if you're done that, you can go back and look at some of the other things that are necessary. Like if you haven't gone this weekend and done this protons and valence electrons, you haven't looked at the 3.1 quiz, you know, if you haven't done your notes for ionic bonds, I would suggest you need to spend some time doing that. Perhaps not today, I'm not really sure. Okay. And then we're going to take a quick look at chemical formulas. Okay. So I'm going to turn the light off here so we can see the screen better. But when we have these atoms combined and we want to show exactly what atoms are involved in the process, we write these things called chemical formulas that tell us exactly how many atoms there are in that particular compound. Like I'm already there. Let me just grab here. Really? I'm like literally logged in. Okay, back through. Sorry for the delay, guys.
your movie popcorn with or without sodium chloride? NaCl? No? Okay. Salt? Do you like your movie popcorn with or without salt? Salt is a substance made up of the elements sodium and chlorine. Together, these two elements form everyday table salt. Sodium chloride is an example of an ionic compound. Trust me, this sounds more complicated than it really is. Basically, each ion is an atom which has electrons and protons, giving it a negative or a positive charge. In the case of salt, the ions from sodium and chloride balance each other out. So just think of an ionic compound as a balanced formula. No negative or positive charge. Now let's take a look at a substance that looks similar to salt, baking soda. Don't be fooled, they may look very similar, but their chemical formulas say something very different. See? NaCl and NaHCO3. The only thing they share is sodium. These combinations of symbols that show the ratio of elements in a compound are called chemical formulas. Baking soda is known as sodium hydrogen carbonate. It is made up of the elements sodium, hydrogen, carbon, and oxygen. Baking soda is a compound containing polyatomic ions. That means ions that have more than one atom. The chemical formula for baking soda also has a number called a subscript. A subscript tells the ratio of elements in a compound. If there is no subscript visible, it's understood that the subscript is 1. Looking at baking soda then, we can determine the number of atoms as 1 sodium atom, 1 hydrogen atom, 1 carbon atom, and 3 oxygen atoms. It might sound a little tricky, but it does get easier. Now try these on your own for practice. Aluminum chloride, sodium bromide, and potassium nitrate. Identify which elements are in these chemical formulas and how many atoms of each type make up the compound.
Okay, I'm gonna backtrack this slightly. So, if you have your periodic table, so you can find the periodic table. Okay, which of these is aluminum chloride? That's this?
Aluminum chloride is AI.
It is not AI.
The top one. Top one is.
The top one is, it is AL. It's important to note, if it was AI, it would be something entirely different because I, the capital I stands for iodine. But we don't have anything that is just pure A. Okay, it's always A something. Okay, AL and 3 Cl. 1 aluminum, 3 chlorine. Okay, which one is potassium nitrate? I don't see anything with a P, do you? So, potassium, where do I find that on the periodic table? What's its symbol?
Okay. It's group 1.
Hey, Christian, can you take the hood off, please? Sorry, the symbol for potassium was?
It's K.
Is K. So K, NO3. NO3 is a polyatomic ion. Okay? And then the last one, what's Na again?
Sodium.
Sodium. Sodium bromide. NaBr. So here we have a total of 1, 2, 3, 4 atoms. Here we only have 2. How many do we have in the last one?
3.
David?
5.
Your name David?
Yes, that's
What's the answer here?
3.
How many atoms are there in total for this?
3.
There's more than 3 because this 3 says there are 3 oxygen and there are 2 other elements that are part of this as well. So Bella, you are correct that there is 5 atoms in this particular compound. Okay? So you guys have a little bit of time, about 15 minutes. I want you to start looking at your test grades. Start looking at the comments for formal lab reports. Okay? And start thinking about which test you might be retaking or how you are improving that formal lab report grade.
What if there was like nitrogen had there were 3 nitrogens and 1 oxygen and 1.
If that were possible, then you would see the subscripts inside of it, like H2O. H2O is 2 hydrogen and 1 oxygen. You'll also notice that it tends to say the metal, then the non-metal. It's just like reading the periodic table from left to right. You have that same sort of thing happening, typically in most cases here. Okay.